practitioners in such a way that just they are making sure that their technology should reach to everyone. Okay, who are really passionate about the data engineering and data science kind of the aspects. So here there is a various kinds of the certification, friends. Like a data engineer associate, data engineer professional, data analyst associate, machine learning associate, and machine learning professional. So these particular certifications really help us, okay, just to manage the convention of. So whatever the genre you belongs to, so just you can make use of that convention. But this course definitely helps you to go ahead with these data engineer associate or else data engineer professional. Okay, and periodically I'll be floating some other course also related to the machine learning, and that time you can venture these three things also. Okay, so uh, and of course data engineer associate and data engineer professional, which are under the scope of the corresponding topics which we are covering. uh, and these things really help us to crack the certifications very easily, friends. Okay, so I strongly recommend you guys, just you can have a look on. Generally in the IST timing, it becomes 8:30 to 9:30 a.m. Maybe before our office hours, you can log in and you can have, because directly the Databricks members itself, they guide us, okay, in what way you can perform the aspects and how to clear the examination and all these things. So why I am insisting on these certifications, friends, because as one of the important criteria for the appraisals. Okay, so and moreover, guys, this certification really gives you some kind of confidence. Okay, at the moment you clear these kind of the things, definitely you are the valuable resource to the team and as well as the company. That's what I am scoping these points as well. Okay, so of course, one of the byproduct I am expecting from you set up the people is at least 50% of the members can able to crack this certification exam. Okay, right, especially these first two things. And ML also I'll be floating, so soon after completion of this thing definitely will talk about those kind of the conventions also. And apart from those things, guys, we're having the basis like these particular series. A few series only exist for the customers and partners, whereas however we are going to see these kind of the things, Delta Lake, all these aspects, introduction to data science and Databricks with ML flow, I'll be covering. But still, if you want to register, so just you can also have that kind of the convention based on your interest. Okay, so these particular series covers cluster creation and sizing and introduction to data engineering with Delta Lake. All these kind of the architectures, batch and stream processing, nicely they explain. And ML flow, okay, because this ML flow is automation where it gives some sort of creation of the models and automating those kind of the models. Okay, these are all really helpful to you further. And if anyone interested to venture their learning in terms of the ML aspects. Apart from those kind of the conventions, just we're having the typical lake house fundamentals, which is also one of the key component behind the success of the Databricks edition. Because this data, the Delta Lake is somewhat which is allowing the things so as to store and as a ETL kind of thing, and it is providing many other aspects, friends, really. Okay, which is the de facto kind of the standard. So which is giving us the way how these particular data is located and pushed into the lakehouse platform, and how we are going to perform the ETL operations and all those kind of the aspects you can consider. Okay, like and most importantly, friends, why I am pushing these things is One is the knowledge sharing, so that you can have a look on the what's going on in the landscape of the Databricks, and how they are pulling the value addition to the appropriate development. That is the first point. Another important thing is so where after attending these kind of the webinars or workshops, you will be getting some sort of subsidy on certification also. If it is $200, then 75% of the things, and only you can pay some $25, 25 percentage or something like that. Okay, so that means out of 100, 75 percentage of the fee they will be deducting once you register for this webinar, and only you need to pay the 25 percentage. Okay, so likewise, many benefits are there, friends, and of course, put aside this money matters, but getting the knowledge and understanding the real essence of the Databricks is really needful, and we have to get the data from authenticated members. I strongly recommend you prefer the Apache or else Databricks platforms or Orially. Okay, because those three platforms are really well, and Medium is there, and some other platforms are there. But first you Google or depend on these areas only, Apache Spark or Databricks or else Orially kind of thing, because they're all proper validation would be there, and whatever the topic you are studying, maybe you feel somewhat terminology wise and explanation wise some complex, but otherwise, once you are indulging into those kind of learning, definitely you will be getting after 1 week or 10 days of following those particular updates and newsletters and blogs. So definitely you will be getting the confidence and access and understanding of those kind of the things. Okay. So just I will be pasting this thing also, guys. Only these two things I am pasting, because why I'm pasting these two things is one is related to the certification where you can venture your activities. Second thing is Lakehouse fundamentals. Lakehouse I will also cover, however. So but before that, just I am giving you the essence. The benefit of attending these seminars is always they talk about the unreleased versions. Okay, but they are not yet published, and they directly open up. Okay, so these are all the things we are going to release in the next week, and this is the way we are dealing, and these are all the approaches we followed, and this is the architecture, and these are all the advancements. Likewise, they will showcase before getting the product into the market. You can see what they are doing, and you can get definitely the excitement at the moment. Okay, so because the market not yet observed and absorbed those kind of the aspects, but still we are able to see those kind of the conventions, as a part of our journey in the Databricks, as a Databricks customer. Okay, right. So this is a little assumption, announcement related to these kind of the aspects. And let us see what exactly the today's aspects really. Uh, Now in the today's session, just we'll be talking about RTD predominantly, and as well as operations related to those kind of the conventions. Now the objectives. Uh, if you consider, guys, just the first thing is um, distribution of the data and partitioning. This is the thing we are going to talk. And then developers view of the Spark, because in a broader way we are having two types of the views. One is the data engineer view, another is the data scientist view, and then the real programming aspect like RTD. Within that RDD, just we'll see what exactly RDD, and then how to create, how to load the data from the external sources, and then we are going to perform some sort of the activities, and maybe we are going to talk about the operations, like some of the transformations and some of the actions, uh, these kind of the conventions. Okay, let us jump start, guys, because you know these particular things are very much important before landing up to the high level APIs. Of course, RDD, Databricks itself, they discourage us to use the RDD orientation. But my opinion is RDD is very good in terms of optimizations and memory based aspect. So we cannot avoid the usage of that particular RDD. Rather, what you can do is you can have a look on that what exactly the RDD specification and how do I maintain the convention of the RDD specification, right? Okay. And moreover, before landing upon what exactly data and partitioning, in the earlier session, we discussed about the architectural aspects of the Spark. Now there is one important aspect, friends. Always there is a confusion, like what is a cluster mode and what is a deployment. Okay, so here, if you consider the cluster manager, in the earlier session we have seen that cluster manager, initially Spark context is contacting the cluster manager, and it is conveying the information to the executors, which in turn manages the resources and all the programmatical aspects. Now there is always a race between cluster types and as well as the deployment types. So let me give you that thing also, so that you can also have a look on that in how many ways we can deploy the appropriate aspects. Okay, so the deployment mode is nothing but after completion of your job, where do you are going, where you are going to deploy, or where you are going to perform the finalization of the aspect. So that is what you call the deployment. And in the observations, okay, so just there are certain deployment modes, friends. So after completion of this topic, we'll jump into the understanding of the data and as well as the partitions, because this is the most important thing to clarify uh, between cluster mode and as well as the deployment operations. Okay, let us have a look on this. So cluster manager types in the Spark discussion, guys, what we have seen is Spark initially designed with Mesos actually, if you consider Mesos, and the default programming language is Scala. Okay, these two aspects are defaults for the Spark, but surprisingly, Mesos was replaced by ARM and Scala was replaced in the sense internally it uses Scala, any programming language, R or whichever Python, but this replaced by PySpark orientation. So up to this we are familiar, because Mesos, though it is a native cluster for the Spark, native cluster manager for Spark, but that time all Hadoop or big data users are familiar with the ARN. They're happy with the usage of the ARN, so that they thought of running this Spark on top of this ARN, and they succeeded also. Okay, the results has shown that very much attractive. Okay, encourage. Okay, they're all results are very good. So that this information we are having, friends, actually from the observation of the Spark design. Now the apart from this ARN, maybe you can run other kind of thing, Kubernetes, open source system for automating deployment and scaling and management of the containerized applications. So the persons who are having the background of Kubernetes or container usage, all these members uh, may be having the information. Okay, especially Akhil and all, they use it to, and even in the earlier big data kind of thing also, he has shown that Kubernetes usage. Okay, right. And another thing is most frequently used kind of the convention is Hadoop Yarn, the resource manager in Hadoop 2 and 3. Okay, And coming to the default, a general cluster manager that can also run Hadoop MapReduce and service applications. But if you consider this MapReduce orientation, guys, Hadoop is a combination of two things actually. If you consider, one is the HDFS, another is the MapReduce. Okay, this is for the sake of the storage and which is purely distributed in nature, memory wise. MapReduce is a programming model actually, which is supporting the parallelism. So why MapReduce is not that much catchy is, friends, for two reasons. You have to convert your entire applications into the key value pair, and all the things may not be possible to convert into the key value pair orientation. This is the first problem. Second thing is, if you are talking about the MapReduce, definitely you should have the knowledge on Java or Python full-fledged. Okay, whereas in terms of Spark and other kind of RDDs, data frames, and it is too early to talk. Definitely today I'll be introducing you some programmatical aspects related to the Spark. Then definitely you realize, okay, you will be realize like how simple the coding in terms of PySpark. So definitely the programmers, though they think complex, but while writing the code, they should feel some comfort, guys. Okay, so for that particular purpose, the programmers who are not ready to leave Java, they can venture their thing in the MapReduce. But as I said earlier, like those kind of the conventions are all batch mode actually. And moreover, in terms of the Hadoop, completely that is a disk based or disk oriented. These are all the issues. And standalone, which is a simple cluster manager included with Spark that makes it easy to set up a cluster. Spark itself, okay, without establishing any kind of the cluster after installation of the Spark. And in that case also you can perform the activity. So like if you are having a virtual machine, on top of that you would have configured this Spark. Okay, you need not explicitly configure your cluster, friend, because this there is a standalone support for the Spark. Okay, so how many cluster types are there? Standalone is one thing. Second is the Mesos. Third is the ARM. Fourth one is a container based Kubernetes. Okay, these four just to recollect. Okay, from our earlier discussion also, we have seen these four are the basic cluster manager types available. We are clear up to this. Now, what is the deployment mode? Okay, so deployment mode, an attractive feature of the Spark is its support of the uh, number of number of countless number of deployment mode, enabling Spark to run in different configurations and environments. Because one of the biggest success factor is at the advent of this ARN, enable the Hadoop to integrate with various technologies, friends, maybe Kafka, maybe Spark or streaming. Okay, because of this ARN, Hadoop got the empowerment actually. So similarly, our Spark is also having various avenues so as to deploy. Because the cluster manager is agnostic to where it runs, as long as it can manage Spark executor and fulfill resource request. Spark can be deployed in some of the most popular environments. Okay, of course, Yarn would be there and Kubernetes, and it is easy to have that particular connect, friends, actually. Because suppose I am running on Yarn or I am running on some sort of Kubernetes. There itself I can deploy. That is a quite simple matter. Okay, wherever you are designing your code, and there itself we are going to deploy. So these two are available, like So actually Kubernetes, we are not having any objection. Okay, because Kubernetes is there for the cluster manager type and for the deployment mode also. But observe here, guys, ARN is available in two modes. Let us talk about those two modes actually. ARN basically, guys, is a Hadoop based cluster management tool. And here there are two things actually. One is the client based and another is the cluster based. Let me show you the convention. Suppose if you are submitting a job, how do I do this particular thing is some Spark submit. Okay. And what I can specify is master. Okay. Client. I'm specifying master as client and deploy mode as cluster. So friends, here I can specify the master as client and I can deploy in cluster, or else I can specify master as cluster. I can deploy in the cluster mode. So the way how we need to understand this thing is just have a look on this convention, guys. We are having three components, no? Spark driver, Spark executor, cluster manager. So Spark driver is nothing but the main function is which is initiating the job, which is communicating with the cluster manager, which is also having the communication with the Spark executor. This is related to the Spark driver. What do you mean by cluster manager? Cluster manager is responsible to allocate the resources to all the Spark driver and all those kind of the conventions. It instruct the executor also to take care about the corresponding Spark driver. That much we know. And Spark executor, which is containing the slots and all the executor informations, so as to run the code, which is so as to run the job given by the Spark driver, assigned by the Spark driver. And after completion of this particular job, the result will get back to the Spark driver. So these are all the setup related to the Spark driver, Spark executor, cluster manager. Now let us understand, if I am submitting my job in the client mode, as said earlier, if I am submitting my job in the client mode, now if you consider the Spark driver runs on a client, not part of the cluster. Friends, very, very important. Uh, like, so what I mean to say here is from the client, I am submitting my job to Cloudera Hortonworks cluster, assume that, which is supported by AWS. Now, just I am submitting my job to the from the client mode, okay, in the to the corresponding Cloudera Hortonworks. Now, where this Spark driver runs on a client, of course, from the client only we are submitting, not part of the cluster. This client is separate, cluster is separate. So client machine is separate, your cluster machine is separate. So machine one, and this is cluster. Now we cannot say whether how many machines are there, as yesterday we have seen like is a single system image. If I am talking about the distributed environment. So if at all the ARN is running in the client mode, make sure that guys, your Spark driver is only executed in the client, not in the cluster. And what about the Spark executor? It is understood now. ARN's node manager container. So friends, here one of the important aspect is, though it is a little different topic because I thought of covering this ARN architecture, but again it is taking 1.5 to 2 hours. Let us see if you are still, if you are demanding me to cover the ARN, definitely I will scope that. But let me see, let me show you this. We are having the node manager and as well as the resource manager. Okay, so if you consider this thing, guys, ARN's node manager container, where the executors are running on the node manager. So we are having a master, which is the resource manager, and we are having node manager 1, node manager 2, node manager 3. Okay, these all node managers, okay, update the status information to. Okay, so all these particular things are updated with the resource manager. So the execution of the things, I mean, the Spark executor, though we are saying in the high level view, these executors, what they are having slots, and these slots are having the tasks. So task 1, task 2, task 3, task 4, task 5, task 6, 7, like that. So each and every task information is going to update with the resource manager. So now you see, so ARN's node manager container. Container is nothing but a resource which is allocating the time and as well as the CPU process. Okay, because every job is requiring some memory and some time allocated by the CPU. So that is what the container is, a resource kind of thing. Now, what about the cluster manager? This is most important thing, guys, because it is pretty clear that Spark driver is something like which is initiating the job submission, and of course, which is running on the client, that we are clear. Second thing is the Spark executor also, which is obviously Aaron is having the node manager and resource manager. Node manager is per machine we are having, so that how many tasks are there, accordingly the Spark executor is going to engage the node managers. This is also clear for us. Let us see how cluster manager is taking part in this running, because our analogy in the context of the cluster manager is cluster manager just initially in Spark driver initially interact with the cluster manager, and cluster manager instruct the executors or the corresponding worker nodes so as to perform or allocate the resources to the Spark driver. Okay, now if you consider in the elaborated way, Aaron's resource manager works with Aaron's application master to allocate the containers on the node manager for the executors. See friends, pretty simple. Like, as I said earlier, there is a resource manager and we are having the node managers, multiple node managers we are having. Now again, let me read that context. Aaron resource manager works with the Aaron's application master. Friends, here application master, which is something like which is taking care about metadata management, all those kind of the things, and to allocate the containers. Container already I have said, like container is a resource pool where the appropriate job should be allocated with the corresponding time and as well as the data. Okay, that is what you call the container or node manager for the executors. See, simple. So cluster manager basically interact with the resource manager, and that resource manager instruct the application master to allocate the resources. I'm using the term interchangeably, containers and as well as the resources on the node manager for the executors. Okay, right. Now, if I am making use of the cluster mode, if I'm making use of the cluster mode. Now there is a chance of comparing between each and every aspect in the client and as well as the cluster mode. Friends, in the client mode, explicit mention of the cluster manager activity is there because we are running in the client mode, but our cluster manager is always pointing to the cluster mode. So there is a little extra mile it has to travel because so as to scope all these kind of the convention. But you observe here. Okay, so let us see if I am engaging the cluster mode rather than the client mode in the submission of the job to the ARN. Okay, now in terms of the Spark driver, what we are observing runs with the ARN application master because it is also part of the cluster, friends. You have to observe that point. If you are running your job in the client, your Spark driver is running separately other than the cluster. Whereas if you are making use of the cluster, your Spark driver is making use of this ARN application master. This ARN application master, of course, is available in the cluster. Of course, that application master allocates some sort of the resources in the form of the containers, and it follows up to the node manager level. What about the executors? In the client mode, node manager's container, Aaron's node manager container, the Spark executor is pointing to. Now, if you see, same as Aaron client mode, because friends, one thing you need to observe. Execution of the job Spark executor activity is not changed because of the client mode or cluster mode, because our intention is to run the task. Task running is not having any distinction, no matter whether I'm running the standalone, local, I mean, add mode or else add client mode or cluster mode, all these kind of the conventions, whatever the mode. So it is easy to observe Spark executor is not going to change even though you are running on the client mode or cluster mode, same as the add client mode. There is no distinction. What about the cluster manager? Cluster manager also, guys, just you see this, and only Spark driver is taking the diversion. If Arn is running in the client mode, then the Spark driver is running on the client mode other than the cluster machine or other than the cluster. Whereas if you are talking about the Spark executor and cluster manager, friends, just to observe that there is no distinction between the client mode as well as the cluster mode related to the Spark executor and as well as the cluster manager, because they're having typical execution strategy. Because Spark driver is something like which is submitting the job, which is getting the results. So in this particular case only, in case of the client getting the job, getting the submitting the job and getting the result should be their separate client in the separate client. Whereas in the cluster mode, of course, it is also moved to that particular container and accordingly it behaves. But in terms of the Spark executor and cluster manager, there is no distinction between client mode and as well as the cluster mode. Friends, I am waiting here. If you're having any doubt, please uh, use the chat window. Otherwise, you can unmute and ask me. Because remaining three are similar, guys, same. Because only client and cluster modes are different. Otherwise, all the other things are normal. Okay, no problem. Take your time just to post your questions so that I can come back on this. So now Kubernetes also we have seen runs in Kubernetes pod, and each worker runs within its own pod, and Kubernetes master. So the members who are who would have used or who are using this Kubernetes, they might be knowing these kind of the conventions. But this is a rare convention, guys, where we are going to use that convention. Majority of the users prefer ARN, okay, because this is somewhat flexible. Because this thing is all already configured with Hadoop and MapReduce and other ecosystem tools like Hive, Scoop, Plume, HBase, all these kind of the conventions, and even Kafka also. Whereas another thing is we're having the standalone aspect where we are pretty clear about that point also. Now coming to the local mode of the execution, okay, where mode is local, and there is a typical configuration enters into the picture, guys, like runs on a single JVM, like a laptop or single node, whereas virtual machine based kind of thing, and your deployment mode also in that way only runs on the same JVM as the driver, because we are having only one kind of the disk, and cluster manager also runs on the same host. So in the local mode, friends, in the local mode, your Spark driver, Spark executor, and cluster manager, okay, runs on the same host or same machine. Especially Spark driver, because we need to submit the job, it is related to the single JVM. Whereas if you are running the executor, whereas the tasks are going to exhibit that runs on the same JVM as the driver. So driver and executor are on the same JVM machine, because we typically have this JVM under the hood of the Spark. No matter whether you are using the PySpark, Python, or some sort of the R or Scala, each and every time these things should engage with the JVM, and accordingly the Spark is going to execute the tasks. Now in the standalone mode, which is a typical configuration, guys, standalone Spark itself is having its own kind of the cluster, can run on any node in the cluster. Maybe I'm having some cluster and I want to engage maybe the node manager or whatever the aspects were provided by that cluster manager. I can run on any node, and each node in the cluster will launch its own executor JVM. See here, this is a typical execution. Each node in the cluster will launch its own executor. Suppose I'm having node 1, node 2, node 3. Okay, so while running the tasks, it is having its own JVM separately, and this is also like that they are separated. Standalone is a typical way of executing. But what about the cluster manager? Can be allocated arbitrarily to any host in the cluster, because there is no restriction, because cluster is a similar kind of the machine. It's not like one machine is having something, another machine is having something. The excellent infra of Azure or GCP or AWS, they maintain unique nature of the environment, guys, because with that only we are able to get the single system image. Otherwise, what happens is if some of the nodes are having high configuration and some are not, then definitely you feel the differentiation in the execution and all. And in that particular case, if you see the distinction at one time, if you are submitting the job getting 5 nanoseconds running time, in the second time, if you are submitting, it is taking 10 nanoseconds. That is not the definite single system image. It is something like a normal client server or something like that. Okay, so it is pretty sure that all the machines which are executed in the cluster mode kind of thing, or which are configured by the AWS or GCP or whichever, then obviously these things should be maintained in a proper way. All are having the equal configurations and all these kind of things. So don't get confused between the cluster mode execution and as well as the deployment kind of thing. In cluster mode, we are having the standalone, Mesos, Hadoop and Kubernetes. Whereas if you are considering the deployment, we are having the local mode of the operation, standalone we are having. Though ARN is repeating, we should be very clear that whether ARN is in the client mode or in the cluster mode, and Kubernetes. So Kubernetes repeated, ARN is repeated, standalone is also repeated from the corresponding modes of cluster manager. Okay, so ARN is repeated, Kubernetes repeated, standalone repeated. Other thing is we're having the local mode. It is pretty easy to remember these things, guys. Okay, and sometimes they're asking local mode of cluster manager. There is no local in cluster manager, friend. That just to observe that point, because sometimes in the certification also they're asking that local mode of cluster manager. There is no such cluster manager type in the local mode. Only we are having these things: standalone, Mesos, and Kubernetes. Okay, right. So now if you are referencing, let me summarize the appropriate thing, the cluster manager types, and as well as deployment modes. Okay, so standalone. Here also we're having standalone. Second aspect, we're having the ARN. But here we are having two ARN. One is the client mode. Another is the cluster mode. Of course, most commonly used kind of the conventions, Mesos. There is no Mesos guys here, no such kind of thing. Kubernetes, and here also we're having and one more thing we're having here is like apart from the Mesos, we're having the local mode of the operation. Okay, so just you observe local mode, standalone, ARN, Kubernetes, all these kind of the things. And in case of the cluster manager types, standalone, Mesos, Hadoop, ARN, and Kubernetes. Okay, hope this is clear for us now. We are entering into the developers view, guys, because these developers views. What I am doing here is I am leaving as a task to you. Just let me paste that what I am expecting from you guys to prepare, because the developer view is something like the developer experience is something like which is in the context of okay, so how we are making use of the interfaces and all these things. I will give you the intro in such a way like the developer's view is the combination of okay, because we are slowly moving to the programmatical construct, so that we need to clarify which are all the offerings of the Spark. Okay, already we have seen this convention. Can someone help me, guys? What is the Spark core? How do you refer that Spark core? Maybe the RDD orientation, data frames, all these kind of the conventions, core of the Spark. Now, apart from these kind of the conventions, we're having the Spark SQL and data frame support, streaming aspect. Maybe individually we are having the Spark streaming, or else with the Kafka also you can perform the streaming. And MLlib, machine learning kind of thing. Yesterday we have seen some of the aspects like classification, regression, all these kind of the conventions. Okay, so this is how you can refer the developer's experience. Apart from this thing, guys, so I want to move to the RTD orientation. So that what I am doing here is just I am making use of the convention, like how we are getting the convention of understanding the projects. So just if you consider, just I'm pasting some link related to this thing, guys. Resource manager and application master. Yeah, good question. Application master is which is monitoring the each task, friends. Okay, so excellent, Surendra. Let me talk about that. Okay, I'll talk about that. I have pasted this link, guys, where this particular link leads to the API references. Let me share that. Okay, already I have shared. You also parallelly you can have a look on this. Okay, so these are all API references where you are having all the kind of the RDD APIs. Okay, this is the reference manual. All the API kind of the aspects you can see. Uh, all the things are there. Let me show. Yeah, if you consider this Spark context APIs, we are having these things. Accumulator, however, I am dealing today. And other thing, broadcast. Yeah, broadcast is also there. I'll introduce you today. And all these kind of the conventions periodically we'll see, not definitely all, but few. And thereafter we are having the RDD APIs. Okay, these are all some of the cache, persist, coalesce, which is pretty required for us. Collect method today, however, we'll see count, collect, take, all these things we'll see. Okay, these are all some of the APIs. And apart from those kind of the things, we're having the MLlib kind of the libraries and streaming aspects. Apart from that convention, we are having the Spark SQL. Now, if you are considering the Spark session, actually, guys, we need to explicitly create this import, and then we should use the Spark session. But can someone help me? What is the reference of the Spark session in Databricks? What is the reference of the Spark session in the Databricks, whether Spark or SC?
Spark. It's
Spark.
Spark.
It's Spark. Very good. Okay, because guys, there are directly without using this thing, imports or something. Okay, your Spark is related to the Spark session actually. Okay, so just you need not have any explicit declaration for that. But whereas if you consider SC, which is nothing but Spark context. Okay, so you need not worry about the imports or making use of the convention. Rather, you can perform the activity. Now, coming to the Surender's question, difference between resource manager and as well as the application master. Okay, let me talk about that convention, guys. I have pasted his question. Let me share the OneNote. Okay, yeah. Okay, so here resource manager, which is responsible for conveying the information to the ARN. ARN, of course, the cluster manager tool, cluster management tool. And this resource manager is a master node actually. Your node manager 1, node manager 2, node manager 3, these are all the slave nodes, friends. Okay, now the point is, suppose I'm having a machine and another like that. Okay, so suppose we are running the task 1 here, we are running task 2 here. Now the application master resides in machine 1. Okay, pick up the appropriate details of the task 2, whether what is the status, what is the percentage of the completion and all. So this application master, okay, this application master available per machine and which is responsible to give the information about the task status. Task status, of course, the task status is updated directly with the resource manager. Friends, be with me. The question is very good question. I have to appreciate Surender. So application master, which is available per machine, and of course that particular application master look after what is the status of the task and how much percentage of the task is completed. Because in the master slave architecture, the slave should update the status with master periodically. So the application master update the information with the resource manager. And one more point I am making here, node manager also update the status with the resource manager. Maybe Sahu or Vedant should answer my question. At that moment also we discussed this point actually in the webinar kind of the aspect. Maybe other members also. It is open question. Just I am referring those two guys because we had some research on those topics. That's what I'm quoting those guys. Now the point is application master, however, updating the task status with the resource manager. Then what is the need of this node manager to update the status of what status this node manager is going to update with the resource manager? So that definitely Surender's question will be answered. One thing is clear, both application master, node manager are going to update the status information with the resource manager. Now the question is, if application master is updating the status of the task, why node manager is also updating the status with resource manager? That is the question, guys. You can use the chat window also if you don't want to speak. I'll be waiting here, guys. Vedant, have you remember the point which I am focusing on? Sahu, because that time you only given some sort of understanding of this application master node manager ARN discussion. That time we have seen maybe long back, na? No problem. Yeah, let me clarify that. Friends, here two important points. The status of the machine, actually, the status of the machine, status of the task, actually. Status of the machine in the sense, suppose 100 machines are there, whether all 100 machines are functioning or not, or whether all machines are available or not, should be updated with the resource manager. Because this is the related to the resource management and all these things. But task is related to the job actually. Because currently all the machines may not have the jobs, but still those machines should operate so as to assign the new jobs. Okay, that is the point. Now, in terms of the task updation, node manager may be containing multiple tasks, but application master picking up of the appropriate tasks, maybe application master pick up the information from multiple machines which are running the corresponding tasks. So it updates the appropriate job information or task status with the resource manager. So that resource manager out of 50 tasks, okay, 35 tasks are running and 15 tasks were completed, like that update. Whereas the node manager update is different, guys. Node manager update is different. Node manager is something like, okay, node manager is something like, which is updating the information about the machine. Okay, whether the current machine is functioning or not. Okay, how many resources are there and what exactly the memory locations, all these kind of the conventions. If any machine is unable to update the status information with the resource manager, then resource manager is going to establish. Okay, one more, it will be connected with one more machine by the admin, and of course compensation of these jobs will be done. Now the question, coming to the question, resource manager is the real master where it is looking after, it is getting the information from the node manager so as to verify whether the machines are, all the machines configured are available or not. Coming to the application master picks up the status information from various tasks and it is going to report to the resource manager so as to convey the information to the so as to convey the information about the task completion status. Okay, so of course, still the question is valid, guys, because as I am saying, resource manager is master. How can I use the application master? Because application master is per machine because it is getting the information of the other tasks from the other machines. And there is analogy. If application master is placed in the same task and it is getting the status of this thing, if something happened to this machine, then there is no possibility of getting the status update from the other machine, because application master itself failed in that machine only. And there is no meaning if same application master is looking after the same machine. Whereas if the application master resides in the other machine, so that at least we'll be having which are all the tasks execution status of the failure machine. That is the analogy between the resource manager, which is a typical master in the ARN. Whereas if you are talking about the application master, it is something like which is a task tracker. Okay, which is tracking all the task information, and the task update is going to convey to the resource manager. Okay, hope it is clear, Surinder. Kannan. Node manager monitor container. Yeah, perfect, perfect. Because yeah, thank you. Right, Kannan. Because node manager functionality is to look after the resources only. How many resources are allocated and how many are consumed, all these kind of the things. Now Sahu returned back. Okay, right, very good. For the reference, guys, just you have a look on this. Always Sahu come up with a summarization. Okay, right, very good. Even I expected from Vedant also. Maybe he's on not on the track. Whether Vedant is on call, definitely he should be.
Yes, sir. Yes, sir. I
Yeah,
was
what a
trying to
yeah,
recollect.
recollect. That time you remember, you only has given the you members so Sahu, Harish, and Vedant. The you three guys have given that and kind of the cluster management, right? Okay,
The
nice
presentation, right?
presentation. Yeah, you're right. Correct. Yeah.
Mhm.
So good. So no problem. So that is what, guys, how we are making use of the convention of this thing. Now let me enter into the genre of RDD orientation. Uh, so this particular RDD is a typical low-level API, guys. Okay, and before talking about the RDI, so let me start the cluster actually, because we need to create the cluster. So what I will do is let me engage the cluster, because without that cluster, there is no chance of running our programs or allocation of the nodes. So 10 to 23. So just I am creating the cluster. And once this cluster is up, then I can start the creation of the notebook. Because without this cluster, there is no use of the notebook. And in the meantime, what we'll do is we'll try to understand the specification of the RDD. Okay, what exactly that RDD and what it refers. And from this point, it is easy, friends. You need not worry about that with your any programming language, because up to this point only there is a little, I mean, complex, I can say, like architecture understanding and how these components are behaving. Okay, all these kind of the things are pretty much important to make use. And from this point onwards, the topics are pretty clear and straightforward. You need not worry about those kind of the conventions. Now, because I'm stopping this partitioning and all these kind of things. Before that, I want to give you some essence of the RDD orientation, so that I'm starting this convention. So API, can someone give the meaning of that API, guys? What exactly API? Maybe Java we are having APIs. Python we are having some sort of APIs. Every
Application
program
programming interface.
application programming interface. What is the
Interface.
use of that, Sahu? What is the main benefit of API? Why we need
It's
to
just
depend on
a
the API?
medium. It's just
Is
a
a medium,
kind of medium, kind of.
is a kind of medium or interface. Like, if I am working with any kind of the streaming or any kind of the application, maybe JDBC. Okay, if you are working with Java based kind of database connectivity, then there should be some sort of interface where that particular interface greatly help us to implement some sort of the applications, maybe RMI if I am talking, or EJB. Okay, whichever servlets, all those particular constructs are having some application programming interface. Those particular APIs are having some significance, friends. Okay, you can straight away say, if you are using the RMI kind of thing, yes, I am using the remote procedure call. Whereas if you are using the servlet kind of thing, I'm using the HTTP get and post kind of the methods. If I'm using the EJB enterprise Java beans, yes, I'm making use of the security. Like especially in the banking applications, it is always preferable to use the EJB kind of aspects. Whereas if you are using the JSP, so there you are maintaining some server pages. Just you can create your own website or web page kind of the aspect. So this API, based on the usage of the API, one can easily observe that, oh, this guy is working on these kind of the aspects. Similarly, Spark is also not having any excuse of that. Spark API. Okay, Apache Spark started with the goal of simplifying and improving the Hadoop MapReduce programming model. Okay, for all the programmers, maybe the programmers who want tons of the code may be disappointed definitely because they want to write 1,000 lines of the code to achieve a simple task or maybe a complex task. But definitely Spark is going to discourage you guys if you want or if you expect uh, tons of the code. Definitely the code is optimized heavily. Code is optimized and lines of code is pretty simple, guys. Okay. To achieve this, Spark came up with RDD usage, which is the core with core foundation of the Spark. So we need to, while talking about the API, first I need to clear the RDD functionality. So the other higher level APIs were also part of the Spark, such as I said, data frame, and as well as data cities, which is there in Scala, guys, but we are confined to PySpark only now, so that we are having low level API and high level API. And with these two kind of the aspects, 90% of your work will be completed. Okay, RDD, especially in the memory orientation, Spark context, some sort of optimization in terms of accumulator and in terms of what you call that broadcast, all these kind of the conventions. Whereas if I'm moving to the high level API, there are data frames. Yes, you are right. If you are having a little background of the Python, there is a in terms of pandas, we are having the series and data frame, that data frame only. How we are managing our data in terms of rows and column fashion. So it's a tabular representation. Okay. Now, even for the more simplification, Spark introduced the Spark SQL. No, still the people are not happy with the data frame of this kind of the thing. Some more simplification is there with the Spark SQL. Of course, the scope of the subject what we are discussing is RDD. Definitely we are going to cover in today's and Monday, and data frame probably from Tuesday I'll be starting. And after completion, because data frame definitely require 2 to 3 days, and thereafter I will be jumping into the Spark SQL. Okay, same thing we are going to rewrite in Spark SQL, some of the examples. So the code passes through. Can someone help me, friends? Catalyst optimizer, have you gone through the yesterday task? Because that is the mandatory thing. Why I'm leaving you the afternoon hours is whatever the task I give, just to focus and clear those kind of things, guys, which is pretty, of course, periodically I'll be revisiting these particular tasks, whichever I will have given to you. Okay, definitely these things I will be covering, but my strong recommendation is whichever the task I assign to you, just complete that. Maybe hardly 30 minutes or 40 minutes of the time. Okay, which decides how it should be executed and follow execution plan. Okay, this is how you can specify the RDD not yet defined, but what we have seen is here that there is a API. API is available in low level and high level, and low level API is the RDD. High level API is the data frame and all these kind of the convention. And then if you are making use of high level APIs, apart from the data frame API, we are having the Spark SQL also. Now we are jumping into the RTD orientation. Okay, just have a look on this, guy. This is the fundamental where this particular thing is hunting us until you are working with Spark. Okay, every time, similarly, we are going to talk about the data frame API in 2 or 3 days. And after that, we are going to talk about the Spark SQL API also. But just these three things are pretty important, guys, because if you clearly observe the functionality and their significance, then there is no confusion between the RDD API, data frame API, and Spark SQL API. Okay, we should be very clear. because APIs in Spark are available in these three flavors. Majoritarily Spark SQL, RDD, data frame. Now let us talk about the RDD API. So which is nothing but resilient distributed data set where each of term has some significance. What do you mean by resiliency is it is fault tolerant. Friends, one of the important thing is our Spark is by design. Okay, by design, it is fault tolerant. Whereas in Hadoop, with the replication only, we are going to get the fault tolerant replication in the sense by keeping that replicas of the corresponding source file to 3 or something like that. Whereas if you are making use of the resiliency is a DAG, which is pretty important convention, guys. Once we clear the RDD specification, we'll jump into the DAG. I'll explain that. Hence, it make it possible to recomputing in case of failure. What it refers is, guys, assume that we are having the source data and source data, we are getting some kind of the information S1, S2, S3, and there is some sort of RDD we are working. And this RDD, after picking up the appropriate source data, this is going to allocate with the machine 1, machine 2, and machine 3. Machine 1 allocated with S1, allocated with S2 data, allocated with S3 data. Assume that. Okay, your RDD is going to allocate this data. So this is the source data, friends. These are all nothing but the executors. Now, suppose this S2 is not available because this S2 portion of the data is unable to process by the machine 2, or else assume that machine 2 got failed. Okay, this RDD, okay, in this particular format, two possibilities are there. Maybe the corresponding partition is not available or machine itself got failed. In these particular situations, what it does is it is having the lineage property, friends. Okay, lineage and resiliency, what it does is lineage is nothing but see in our maybe if you are having some kind of grandparents and before that, okay, just that is nothing but the lineage. Okay, lineage is nothing but reaching to our source without any hassle. Similarly, RDD also just it is moving back to that source. It is maintaining the kind of the communication with the source data in terms of the lineage, and it is going to recompute. Okay, whatever the portion of the data required, recompute, and it is going to assign with the either with the new machine, or if the machine is available, that particular portion will be given. So that means RDD is fully fault tolerant, though if any problem is there for the portion of the data, RDD can go back with the property of lineage. It can go back and it fetch the corresponding portion of the data and it will be replaced with the corresponding failure mode. Okay, that is how you can refer the resiliency. Distribution, obviously, guys, distribution we were talking from yesterday, like a data set for Spark RDD resides in multiple nodes. Okay, that means the distributed environment is a single system image where I can allocate. Okay, so the appropriate machine rather than working with the single machine, if I am able to engage multiple machines, obviously we'll be getting some kind of the time benefit. Okay, fastness also increase. And data set, of course, which is a name given to the record of the data that you will work with. Some portion of the data that is nothing but the data set. So out of these three words like resilient, distributed data set refers to the data or records. Distribution refers to the your RDD is going to place the data in multiple locations. Resiliency means if any failure is there, if any problem is there, then it is going back in the lineage fashion and it is picking up the appropriate portion of the data and it is placing that particular failure data into with the corresponding machine. So this is how you can refer the RDD orientation. Now, but whereas if you refer in Hadoop design, RDD is a challenge because however, with Spark RDD, the solution seems very effective due to its lazy evaluation. I'll show you friends what exactly the lazy evaluation is. Lazy evaluation in the sense there are two operations actually in our Spark. One is the transformation. Again, second is the action. Transformation is something like which is fetching the data or some filtering or some sort of the data manipulation. But action is something like getting the appropriate information, maybe displaying the data, count or collect or take. All these things refers to the actions. Until the action is demanded, until the action is triggered, there is no, there is no no requirement of the task transformation execution. So whenever there is a requirement, then only we are going to perform the activity. Okay, that is what you call the lazy evaluation. Even students or even some of us also, whenever there is a exam tomorrow, then we'll prepare today night only. So that is what you call the lazy preparation. Similarly, Spark, the lazy evaluation, so which saves a lot of time because whenever there is a requirement, then only it is going to fire. So RDD in Spark works on demand basis. Whenever there is a requirement, then only the action will be triggered. Hence, it saves lot of data processing time as well as efficiency of the whole process. Okay, so laziness should be avoided in terms of the humanity or human, but whereas in terms of Spark, in fact, lazy evaluation is benefited actually. Okay, now the map reduce, as mentioned earlier, guys, is many shortcomings. Like you have to fully equipped with the all the programmatical aspects and should be familiar with the key value pairs, all those kind of the aspects. But with RDD or with the data frame, just you can many optimizations are there so that you can have a look on those kind of the conventions. Now let us go back to our Databricks edition. Let me see. Yes, our cluster is ready. Now let me share the screen because guys, once this thing is over, then we'll come back and discuss the thing because rather just to see that once you complete these aspects, and if I am saying something about that point, so already if we are executing some sort of the task, then it would be easy for us to connect the dots. Okay, rather than just conceptually understanding. Now what we'll do is just we'll create a new notebook and I'll be giving the clear specification session 2 RTD topic 1. Maybe I'm having another topic related to that. And cluster already attached, guys, because earlier cluster is not in force. So cluster already attached, the current cluster create. Okay, now it is giving us brand new this notebook, and which is very similar to Jupyter notebook, guys. Okay, so just I'm giving some RDD create and other operations. Okay, like we'll see this kind of the convention. Now, initially, guys, just to be as a habit, like whether these things are properly configured, automatically it configures, guys. Just I'm giving you this Spark, which is the Spark session, as I said. Okay, Spark session reference variable. Similarly, we'll be having the Spark context, where which is the reference of the Spark context. Can someone differentiate between Spark session and Spark context, guys? Maybe you can use the chat window. What is the difference between Spark session and Spark context? Let me ask you this thing so that I'll be getting some answers. Spark session versus Spark context. Okay, just think through and come up with your analogy. So we observed that our Spark and Spark context are in force. So just to observe that whether our cluster has been attached or not. Now, one important point here, guys. So interchangeably, we are using the Python-based kind of the constructs also. The type is a methodology where if you want to identify the type of the corresponding object. If I am verifying type of my Spark object, it gives that PySpark.SQL.session. On that, we're having the Spark session. Okay. Now you might have realized, like, session is something like, um, suppose if your session management is there, friends, actually, in terms of Java and SSI. Okay, all these kind of the secured session management and all. Session is something like if you are logging into some of the application, it maintains one log for us, like when he has logged in and all the browsing information. Okay, so it is making some kind of the transaction boundaries, login time, logout time. That is what you call the session. Is a typical window. Here also Spark session focus on that particular aspect and it is maintaining the session orientation. Similarly, if I am making use of this Spark context, just we are having the see, friend, that differentiation. If I'm talking about the Spark orientation, I'm having the support of the session and Spark session. Whereas if I am talking about the Spark context, DB runtime, Spark connection, remote context. Okay, so we are just connecting Spark context, just we are establishing a kind of the connection. That is the distinction, guys. So Spark, and one more important distinction, other than this, the conceptually is one dot X typically depends on the context only. And as I said earlier, we need to explicitly mention the Hive context, SQL context separately apart from the Spark context. Whereas if you are mentioning the Spark session, logically from 2.x and 3.x, we habituated to use the Spark session. That Spark session by default allows so just it is making use of the convention, integration of Spark context, Hive context, and SQL context. So it is always preferable to go by Spark session, right? Okay. Now there are two conventions, friends. The first convention is I want to create RDD with parallelize method. Okay, with the parallelize method. Now, friends, here you need not explicitly parallelize or you need not explicitly establish a parallel process related to your Spark programming. By default, okay, either RDD or data frame or other Spark SQL kind of the constructs, whichever the API we are using, by default nature, friend, that is how we are. We need not take care about the parallelism and distributed aspect. It's a de facto of the Spark. Now there are direct conventions. Let me create one list here. Okay, for the sake of simple understanding, I'm having some data. If I'm verifying some data here, obviously it gives the list. Okay, typical list kind of thing. Okay, now what I'm doing here, guys, just I'm creating my first RDD. Okay, RDD means do I need to use Spark session or Spark context? RDD, low level API, Spark session or
Spark
Spark context?
context.
Definitely Spark context, because just it is taking use of these things. So low level API, we always prefer usage of the Spark context. And there is a functionality called parallelize. Okay, after giving that particular thing, just you can first time it is just automatically it is giving the IntelliSense. So if you click on this dot, obviously the appropriate members, whatever the functionalities associated with that Spark context, you can take. So now I want to take this help of parallelize method. This method allows us I can submit my data here. Actually, my data is having 1, 2, 3, 4, some sort of the information, and I am shift enter. Obviously, I can get the outcome. See here, RDD1. Now, this particular parallelize, if you want to get the information about that, shift tab, okay, which is giving some kind of the help, guys, actually. So what it refers is distribute a local Python collection. Maybe that is a list or dictionary or set or whichever, to form an RDD using range. Range also I'll introduce, guys. Range also will use. Recommended if the input represents a range for performance. So, and moreover, my strong recommendation, guys, you need not go any blog or any other kind of the website. If you want to learn above and beyond, just within the Databricks notebook itself, you can have plenty of opportunities to learn and to explore more. So whenever you want to get some help, so try to use this particular documentation. And one more important thing is why I'm insisting this documentation usage is in the Databricks certification exam also, just will they will be providing us some sort of the documentation. So that particular document, if you want to surf and if you want to explore, you should have the experience of surfing the documentation basically. So just you can make use of this convention, and the examples given by this particular document are fine tuned, and it is always preferable to make use of this kind of the thing, right? So again, I'm coming back. So distribute a local Python collection to form an RDD. Using range is recommended if the input represents a range for performance. Just I am taking the collection, okay, and then I am passing that particular collection to this particular RDD. Now up to this guys, just if I am making use of the convention of RDD, if I am giving this one more aspect, suppose I am taking the same example and I am making use of the example like this, and I am giving the data one. Now you see data one is not defined. Okay, obviously, if you are even if you are not mentioning that particular thing, it is going to uh, raise some error kind of thing. So now if you want to get the explanation of that thing, just it is giving that name data one is not defined, simple, and trace back. If you consider the error kind of the situation where how Python is doing the specification in the similar way, it is also giving the erroneous kind of the conditions. Okay, just observe that point. And now we are ready with our RDD1. Now we are going to perform some kind of the activities. Let me jump into this RDD1 dot. If you give the tab, whatever the functionalities associated with this particular RDD, you will be getting. Okay, now if I want to pick up the appropriate information which is available in RDD, I can simply give this. Okay, see here guys, just it is running, and there are specifications of the Spark jobs. If you want to view, okay, see jobs, stages and tasks. Now you click on this view, which will be provided with UI, Spark UI. And maybe guys, actually we are using the community edition. We may not get the entire aspects of the, I mean, the job functionality. Whereas if it is the proprietary edition, then definitely you will be getting things. Now there is explicitly we need to study about the DAG. Okay, shows a graph of stages executed for this job, each of which can contain multiple RDD operations, maybe the map, filter, and of RDDs inside each operation. So the diagram itself gives the understanding of how this particular DAG is performing the activities. And all these DAG visualization help us guys how internally this particular thing is executed. Okay, of course, this is a so simple example. Just we are creating the appropriate information and just we are taking some collection, and accordingly we are running the tasks. Now you see here. So just as mentioned earlier, we're having the jobs, information about the job. Okay, all these kind of thing, stages, which is how many stages we are having, all these kind of the conventions, storage representation, okay, and environment, and we are having the executors. Okay, executors which are there in the worker node guys. Okay, in the worker node we generally having the executors. Executors are having the slots, and that particular slot generally gives the allocation or container, I can say, allocation of the appropriate tasks. Okay, so likewise, this Spark UI really helps us to get into the genre of the jobs information stages. And if I want to get some kind of the initiation of the DAG, all these kind of the aspects you can specify. Up to this only we are having the access, because this is not a full-fledged edition. That's what we are unable to access that. So now this particular collect generally shows the corresponding aspects which are there available in the RDD. Now to clarify, just let me show you the type of this RDD. Obviously, PySpark.rdd.rdd. Okay, just we are having the convention or hierarchy of this RDD specification. Now let me we have created some RDD and we applied some kind of the convention of parallelize. Now how do I process this RDD? Process means I have to make use of that data and I want to perform some sort of the actions. Now there are certain transformations, friends. Actually, transformations and actions. Uh, until the last session, we are going to talk about some or other way about the transformations and actions. And day by day, at least 4 to 5 transformations or 4 to 5 actions we are going to learn. Like out of 30 or 40 transformations, at least 10 to 15 will study. And next day, maybe it will be popped up with 4 more new transformations and 4 more new actions. Like that, the list will increase, friends, dynamically. So even at the end of the course also, we may left with some of the transformations because those transformations may be related to the streaming. Maybe some of the transformations or actions may be related to the machine learning kind of the constructs. So, but however, as a task, I'll be giving you some sort of the transformation table. After completion of this particular explanation of the RDD, we'll come back and discuss about the transformations and RDD. And exclusively, guys, the discussion about the transformation and actions very significant in the data frame discussion because there is we are having plenty of opportunities to study about the transformations and actions information because those things really helps us to feel the real capacity of the Spark and real programming strength of the Spark. Okay, now so just we are making use of one transformation. First let me write the code, guys. Just I am making use of RDD2. Okay, so new RDD I want to create. Again, what I'm doing here is earlier we have seen, let me use the range function so as to create the RDD. So friends, here range is a functionality where you can create some range of values. So if you are having any doubt, just you shift tab. Okay, so just it is giving the parallelize operation, whereas your range functionality takes some starting point and as well as the ending point and step function. Okay, so just with this particular arguments or parameters, the range is able to create some sort of the values. Okay, some sort of the collections. Now there is a functionality called map. If I'm clicking on this particular thing, map is a transformation which takes generally the lambda function and calls it a loop for each time. Now, friends, if you are having the background of Python, you might have observed the capacity of the lambda function. Lambda function is something like which is an inline function where if I want to execute some sort of the functionality without any without any loops or without any static variables or all these kind of the conventions. So there is a provision of running the appropriate functionality or code or logic within the line so that these lambda functions are anonymous functions which they are not having any name for the function and they are inline. Okay, within that particular line only they are going to execute. So this is how you can manage the functionality of this map. Now, within the map, just let me use the lambda function, which is a pretty simple aspect. And each and every variable, I can take X or something. What I'm doing here is uh, first put this particular X value and thereafter add the value of this particular thing like that. Some simple logic I'm writing here, guys. Okay, so this logic, what it does is, let me show you the outcome so that you can realize. So now in this particular functionality, what we have seen is we are parallelizing rather than data. This time we are using the range function so as to generate the values. We are applying this lambda is something like which is allowing us to give some sort of the logic, and map is a transformation where I can perform some sort of the activities. Okay, map functionality. What exactly is the transformation which takes the lambda function as an argument and it loops every time because I'm having some sort of numbers here, range of numbers. And one more important thing, guys, if you observe in the earlier example, Just we have created separately the data. On top of the data, we have created this RDD. If you observe the current statement, we are not skipping, or we are not completing the creation one time and completing the logic one time. We are trying to achieve the creation of the RDD and performing the logic similar time. That means what we are doing here is, guys, just we are making use of the convention. Like whenever I am performing some sort of the activity, of course, in any object oriented programming we are having from Python onwards, it's not specific to the Databricks or Apache Spark. Of course, always, if I'm using Python, I'll be inheriting the properties of Python into my Databricks notebook. And if I am having the background of the Scala, and obviously the Scala based kind of the imports will be taken with respect to Databricks. And even important point is for the Spark, Scala is the native language. So even in simplest form, I can make use of those kind of the conventions. So it all depends, guys. Like it's not like I cannot separate these properties Databricks and these properties from the Apache and these properties from the Python. That the beauty of this technology is, like, is a single system image, I would say, because I cannot say whether this is Python inherited or Databricks inherited or Apache Spark based inheritance, nothing like that. Okay, because as a programmer, we need to enjoy the benefits as a whole. As a holistic development, will see obviously these kind of the conventions. But at the outset, maybe I can say in Python, that is something like object orientation, like object dot something, and I'm going to execute the functionality. But in Databricks or in the genre of this data engineering or data science based, just we'll be talking about the pipelining actually. Like I will be taking some sort of the information and we are going to apply some sort of pipelining aspect, right? Okay. Now, once this RDD is created, now the action here is I want to collect the information. Just if you are making use of the convention, now simply you will be getting the convention. Like just what I want to do is friends, here there is a operator. Like if I am giving the star there, obviously it is going to multiply. Okay, multiply in the sense it is going to get a replication of that in specific to the Python. Now what we are doing here is, guys, just I am taking 1, 2, 3. You might be knowing about this functionality of the range. Okay, suppose if I am giving 1 comma 4, your 1 is included starting subscript, and your 4 is excluded. This is a general property. Excluded in the sense it runs from up to 3 only. So the same kind of the convention. Now what it does is with this map functionality, just we are replicating this value of x. X value is 1, x value is 2, x value is 3. And those many times just we are replicating the value of a. 1, accordingly A is replicating. 2, accordingly A is replicating. 3, accordingly A is replicating. Some sort of the functionality, guys, because lambda function, even I am saying 100 logics, you might go with the 101 logic, because those many avenues are there for the programmers and developers. Okay, just I am focusing on the functionality of understanding the RDD orientation in terms of operations of the RDD. Now, one more important point, be cautious, guys. Up to this, pretty simple. Now we are slowly entering to understand the aspects of the RDD orientation. As always, I'm keep on saying that RDD is some sort of the memory orientation, and which is a low level API. Now at the moment, guys, we got some RDD2 here, and I want to save. Okay, save as some kind of the sequence file. I want to store this particular file uh, in my directory. So where there is a path, actually in the earlier session also I have shown to you. Let me move back again. Just I'm opening the path of the corresponding thing. There is a DBFS basic directory, guys. Within that, preferable thing is the file store, and within that we are having the tables, and accordingly just I can pick up the appropriate file. So now the path is like that: file store slash table slash all, or if I want to pick up order one, accordingly just it is going to give the specifications. Okay, Um, Now, if you consider this particular aspect, so always prefer, otherwise if you are not giving also no problem, directly it goes and it stores here only. But it's not a good practice, guys. Explicitly mention that particular path so that at later point of time also you can pick up that particular information without any problem. So just to follow some standard so that in even in projects also you can have a look on that kind of the convention. Now, based on the basis of this, just we're having the hierarchy like this dbfs colon file store slash tables. This is the path. Okay, whatever. Now let me copy this, move back to our thing, paste here. Okay, so as to avoid the errors. Now remember, you need to place this dbfs colon and this is a path. Na? Just we need to mention the string. Now what we're doing here is, guys, just I am mentioning that uh, so just I want to store the data. So what I am storing here is RTD new, like that I am storing. So now it is easy to pick up as we are running our RTD and I want to store this particular RTD in my DBFS file system. So we have to close this thing. Otherwise it is showing the red colored. If you miss out this thing, that is the beauty of Python, Databricks, whichever. Even in Python Jupyter Notebook also will be getting the same kind of the support, IntelliSense. Now we'll try to understand what is this save as sequence file. So just the save as sequence file initially take the path, which is a string, sorry, which is a string kind of thing, and output a Python RTD of key value pairs or RDD. Key value pair also I'll be introducing the dictionary kind of thing to any Hadoop file system using the writable types that we convert from the RDD keys and value types. The mechanism is as follows. Okay, just it is managing the convention and it in a way it is mentioning the other kind of the things also. Okay, have a look on that. But basically what we are trying to do here is just we are trying to save the corresponding file in the specific location where uh, as I mentioned earlier, just you can go and pick up this particular path. Just you click on that. Obviously this interface is giving some kind of the path. Paste that if you don't want to type, so that you will be getting this thing up to tables you keep as it is, because this thing is prefix for every file. It is prefix, especially in our community edition, and just you can give the RDD new some sort of the information. Now just if you run through this thing, guys, okay, it is not going to give any outcome because just we are trying to store this particular data, and surprisingly earlier only few jobs, okay, only one job here, but whereas it has taken multiple jobs here itself, you can say parallelism. So parallelly it is picking up that particular data, it is going to store that data. Now I want to see that how it is whether it is in what way the format of the RDD new I can observe in the appropriate storage. Just I am going back and I am selecting this file store once again for the sake of the refreshing, just to take the tables, and then our file name is RDD new actually. Let me pick up that RDD new. Just a minute, guys. Yeah, this one. It is in the form of the directory. If you click on this particular thing, again, it has applied various partitions. However, we are going to talk about data and partitions in a while, which is again consolidating the revisiting of the transformations. Okay, so the point here is, guys, if you observe the kind of the representation here, one thing is pretty clear. It is not going to store as a single file. It is taking as a partitions, though the file is pretty simple. That is what the beauty, guys. Here big data technologies don't change their intention of storing or processing the data, no matter whether you are using the small file or bigger file. Big data itself intended for the larger files only, so it follows the same kind of the convention. Okay, so it is not going to change its way of running the code uh, as a context of small files or the context of the large files. It follows the same context, no matter whether you are using the small file, medium file, or larger file. Now, keep this point in mind, guys, because At the moment, I am making use of the convention like whatever the functionality we are using. So just if you are making use of the observation here, my DBFS file system is provided with these kind of the conventions. Now, for the sake of your reference, just I am pasting these kind of the things. Uh, Danush, Surya is asking, focus on the current thing, friends. Focus on the current things. Don't travel ahead, and I don't want to disturb all the 30 members in the call. Okay, if I'm dealing with that parquet file, definitely you ask the relevant questions. Okay, otherwise connect me with in the offline. Okay, I'll deal with that. Be in the current scenario. But the problem with the human beings is will be thinking more. That is the problem actually. Be in the current situation. That is my request and suggestion also. Okay, as a mentor. So don't travel ahead and don't think too much. Okay, definitely whenever the topic is there, accordingly you can ask. Otherwise, if you want to move ahead, personally contact me. Okay, we can travel like anything because I don't want to disturb all the other 30 members. Okay, right. So now, if you are considering the situation of this thing, keep this point in mind that the storage, whatever the storage we are doing, that is splitting and it is parallelizing some partitions kind of thing. This is a partition. Okay, part wise it is going to store the data. That is what the reason if you go for the help. Okay, just it is taking the Hadoop file system. The people who are having the background of the Hadoop, especially in the Hadoop distributed file system, and while running the MapReduce job or while performing any piglatin or Hive based kind of the scripting, ultimately it is going to store the data in the partitions, friends. It is not it is not storing the data in a single file. If you observe guys here, it is also taking as a directory. Just we are mentioning the RTD new as a simple file name, but finally what it does, it is kept that particular RTD new as a directory. Accordingly, it is placing the files. Okay, accordingly, it is placing the files. Now, you may be having this doubt while processing. Do we need to pick up the individual partitions? Okay, so let me clarify that. Spark context. Of course, I want to pick up the sequence file and the same path, whatever the path I have stored, just let me pick up that thing. Okay, the path. Now I want to collect the data. Okay, just I don't want to store the data, just I want to collect the appropriate data. So whatever the file methodology I'm using, whatever the file just now I have stored, and I'm not giving any separate partitions or any specifications, guys. And one more point, if you observe, there is a factor called success. Actually, if you consider while running these kind of the jobs, guys, every time it is saying some job one, job two, job two, three like that. So it means that after successful completion of the job, after successful completion of the job, just will be getting the Hadoop or big data kind of aspects like Spark and all. They will be returning whether that job is success or not. Okay, it is a kind of observation. The point here is as we are dependent on the multiple partitions and heavy data loads, and even some of the jobs are taking much time. Those jobs are nothing but multiple jobs are running and they're all parallelized and they're accessing the distributed information, all these kind of the conventions. So the point here is guys, at the end of the corresponding job, the engine, no matter whether that is the Hadoop or Spark, ARN or whatever the cluster manager we are using, the responsibility of that cluster manager is it should return back the status of the job. That is the commitment of the master slave. Na? Typically, master slave architecture, after completion of the job, it should update the status information. That is application master and node manager, how they are updating with the resource manager. So this is what how you can refer the success. But our talk here is whether this particular file, do we need to explicitly mention partitions or can I just mention my file name, whatever I have given. Let us see what happens. Just I'm trying to run this. Collect is a action where I am able to get the information. Now see here guys, one simple analogy. Here I require 5 jobs so as to store this data. And here I only require 3 jobs to pick up the data. Reason is pretty simple. Uh, I'll be talking about the partitions in a while. Like, what exactly the Spark or Hadoop does while running the job is they generally prefer higher partitions, like so as to parallelize the data or so as to handle the appropriate conventions in the simplest way, so that it initially started with 5 different zoners, and accordingly it is going to launch the jobs, which in turn launch the stages, and the stages again containing the tasks. Likewise, it is going to perform the activity. Now, at the time of accessing the data, we pretty clear that, okay, which are all the partitions are having the real data. Okay, so just it is enough to launch only 3 jobs, because the Spark engine is aware of how many partitions are really having the data. Only those many partitions are going to pick up, so that it is not having any confusion. It is not having any, I mean, speculation kind of thing. It is having the solid understanding of this particular number of jobs requirement. Accordingly, it is going to pick up the data. Now, if you observe whatever the RDD2 we picked up from the earlier stage, maybe here, yeah, here, whatever we have picked up, the same kind of the thing we are getting without any change, guys. That is what, friends. Even after using that particular data, it should not touch base the corresponding source data, though it is using many kind of the manipulations or some sort of the operations it is doing. But definitely it should observe the corresponding aspects, like as it is. It is not going to perform any activity or any kind of the change to the original data. Now we are moving ahead with RTD operations. Yes, I know it is a time to break. Okay, so just we'll have the break, guys. And before that, let me consolidate which are all the things we have taken. And now we are making use of that kind of the convention. Okay, like ah. Yeah, partition, guys, just I will be talking in a while. So because default partition is 8, of course, it is a community edition. It is 256 in the proprietary edition, like that. Now, but you can repartition that. Okay, that thing, however, I will be covering in a while. And let me see how many of you answer. Yeah, Surender says Spark context is into low code. Did an entry point to Spark, and Spark session seats above it, which is PySpark. Okay. Asflosen says Spark context is the gateway to Spark, through which user is able to create and manage the data. Spark session is also the gateway, but the distinction is all the context introduced in the 2.x. Shanmuga says has Spark context, Hive context, and SQL context, whereas entry point to Spark. Good. Vedant says Spark context is used to establish a communication with the cluster, and the resource managers act as the entry point to Spark. Good. Spark session was introduced in 2.0, which is available to perform all the other kind of the aspects. Uh, Partition, that's what, friend. Default partitions are there, which is by default 8, but otherwise you can change that thing also. That is the default kind of the nature. Okay. Now